Okay, because of the extra y you've put in due to the pumping. Well, therefore, this string here does not obey this condition, and therefore this string does not belong to this language. Okay. Now that's just case 1. Now, how about case 2? Well, it's similar, except that y now, instead of consisting of all zeros, now it consists of all ones. Okay. Now, with the same argument, now x, y, z had an equal number of zeros and ones, but now you've got an extra y, and this y consists only of ones. So now you have too many ones, right? So now x, y, y, z will have more ones in it than zeros. Therefore, it doesn't obey this property. You know, it's not one of these strings. Therefore, this string x, y, y, z does not belong to that language. Okay, so you got a contradiction in the second case. Now, how about the third case? Now, the third case was the one left over. Now your y, there are only 3 possible cases for y. They're all zeros, they're all ones, or there's a mix. Okay, a mix of zeros and ones. Now, this third case, so assume your y now consists of a mix of zeros and ones. Alright? So now have a look at what x, y, y, z will look like. Well, y is a repeat of y, right? It's a clone. It's a copy. So if y is a mix of zeros and ones, you'll get that same mix repeated here the second time. Alright? So can you see then there will be at least there'll be a 1 with a 0 in between it, at least 1 0 in between, and then you get another one. So you'll have 1 0 dot 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 1. So you won't have something in the form of 0 to the n, 1 to the n. You won't have all the zeros on the left and all the ones on the right. Okay? In the middle here somewhere, you'll have they'll be out of order. You'll have 0 0 1 followed by a 0. Okay, and hence it's not of this form. So therefore, this third case, so x, y, y, z is not of this form, because you don't have all the zeros on the left and all the ones on the right. Okay? So this third case also doesn't work. It's also contradictory. But that third case now completes. You've now got all 3 cases, all 3 possible cases, where that string is not pumpable. Like the condition that the pumped string belongs to the language. Well, in all 3 cases, the pumped string does not belong to the language. Right? It does not have this form when pumped. Okay. Well, therefore, we found our counterexample. We've found a string S that cannot be pumped, and therefore the pumping lemma doesn't follow. But the pumping lemma was a consequence of B being regular. But we have a counterexample to the pumping lemma. Therefore, this language here cannot be regular. And we've done it, right? So we've proved via proof by contradiction, using the pumping lemma, that this language is non-regular, right? Okay, next example. So much of it's the same. We're given a language, and we have to show that that language is non-regular, and we will use the same approach using the pumping lemma, and we'll find one counterexample, and hence this language is non-regular. Now, that sounds as though they're just doing a repeat of what we did before. So what's different about this one? Well, the choice, what's different is the choice of your string, your candidate string that you're going to use, your S, that you're trying to show is not a member of the language, the counterexample. It's more subtle. You may choose something and you'll find that it actually is pumpable for certain circumstances. Yeah, the same string. And in other circumstances, that it is not pumpable. And that's the subtlety. So this second example will go into that. Now, I'm being a little vague, but you'll see what I mean as we go into it. The second example is more subtle. There's a complication compared to the first one. Okay, well, you'll see what I mean as we get into it. All right. Okay, so all that's much the same. Here's another language. Well, before was B, now it's C. Okay, so it's a set of strings W, and these strings, the alphabet as usual in both cases. I didn't mention that. The alphabet is binary. Two symbols, 0 and 1. Okay. Now the strings in this language, they all have an equal number of zeros and ones, but they don't. All the zeros do not have to be on the left-hand side, and all the ones on the right-hand side. It's just an arbitrary string, right, of zeros and ones. So it's just a random bit string, except with one constraint, that the total number of zeros and the total number of ones is the same. Okay, that's what this is. So with an equal number of zeros and ones in the string W. Okay. So you use a pumping lemma to show that C is non-regular. Just as we did in the previous example, right? Yeah, that's the previous example. All right. Now, again, the critical factor in your proof or disproof is choosing your candidate string S that you hope to be the counterexample. So here's again a critical choice. So let's take this choice as the potential counterexample, a string that maybe cannot be pumped. That's what we're trying to show, right? So let's take this as an example. So our strings of the form 0 to the P, 1 to the P. So you are putting all the zeros on the left and all the ones on the right. Now this string satisfies this, of course, because we have P zeros and P ones. So the number of zeros and ones is the same. So this string S here with this property, it looks like this, is a member of C, right? Because P here and P here, number of zeros, number of ones are equal. So S is a member of this language. All right. Now the length of S will be, again, just the same as the previous example. The length of S, number of symbols in a string, will be 2P, right? P zeros and P ones, so 2P. Now 2P is larger than P, right? Now this string belongs to the language. Its length is greater than P. Now what is P? We've let P here. It's the pumping length. So just the same as the previous example. So far it's pretty much the same as the previous example, but you'll see a complication will arise, and you'll see that happening early next session, running out of space in this session. Okay, so it belongs to the language. We're assuming the language is regular. Okay, the length of the string is greater than the pumping length, little p, because we let p. Where was it? Let p be the pumping length. So therefore, this string here that belongs to a regular language and its length is larger than the pumping length. Therefore, the pumping lemma specifies, dictates that string S here can be split into 3 substrings X, Y, Z, such that the 3 conditions hold. In other words, the string XYZ is pumpable, meaning X, Y to the I, Z also belongs to the language. and the other two conditions. What were they again? The length of y is positive and the length of xy is less or equal to p. There's three conditions, right? Okay, so S, you can split S in these three ways. The string, I hope you can see this first line of the next session. So the x, y to the I, z belongs to the language, C, okay? And now we're going to try to show that this is impossible, similar to what we did in the previous example. But then you'll see a complication arises, and that will be the difference qualitatively from the previous example. So this example contains a bit more subtlety, a complication compared to the previous one.